All right, so we want to do the same thing with this rational function, but the problem is the degree of the numerator is greater than the degree of the denominator. So we're not going to be able to just write it as the sum of two proper rational functions. So what we're going to do is start off with polynomial long division. So we're going to put x squared minus 1 into x cubed plus 0x squared plus 3x plus 0. And what do we need to multiply the x squared by to cancel out the x cubed? That's just x. So I get x cubed minus x. And then, as always, I'm going to remember to subtract so that this becomes 4x plus 0. And 4x is degree 1, which is a degree lower than what we're dividing by. So that's our remainder. And what that tells us is that the rational function we started with is equal to x plus 4x over x squared minus 1. Okay? So now we're going to do partial fraction decomposition just on the 4x over x squared minus 1. So let me just write the 4x over x squared minus 1. I'll factor. And then I'm going to write this as a over x plus 1 plus b over x minus 1. And when I go back to try and create common denominators, I'll get a times x minus 1 plus b times x plus 1 over x plus 1, x minus 1. So I'll get that 4x is equal to ax minus a plus bx plus b. So that 4x is equal to ax plus bx. And I don't have a linear term on the left-hand side, so I'm just going to write 0 is equal to negative a plus b. So I get that 4 equals a plus b and 0 equals negative a plus b. So this guy is going to give me that a equals b. And when I plug that in, I'll get 4 equals a plus a, so that a equals 2. All right, and that gives me that b equals 2 as well. So that this guy ends up being x plus 2 over x plus 1 plus 2 over x minus 1. And that is our partial fraction decomposition. And yeah, I know what you're thinking. These really are super fun.